Bam, 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 bam.
Now, those of you who already know, this is one of the in our electrical shop. Just so happens, this is Tate's booth. Tate couldn't be with us today for our making our video because he is actually working on electrical with his dad. I was actually going to use Smiley's booth, which is booth down, but Smiley has an LED overhead that is extremely bright and it actually interferes with the camera. So as you can see in the background here, I'm actually at Tate's booth. Those of you that are familiar with our booths know his light is not on. That means that his box is not energized. It's not hot. All right. I was going to ask if you guys would mute yourself because I hear a lot of background noise.
Yeah, it's Shane on that one. And it doesn't
Shane,
look here.
Mute
Can
yourself.
you mute him?
I'm going to look see.
I know you can unmute.
I can't even find Shane on here. There he is.
There we go.
All right, very good. I hate to do it, but it's a distraction to me, and I know it's a distraction to you guys. All right, the first thing I want everybody to do is take your multimeter, unwind the leads, separate them. I know they get wound up and they actually get stuck together. When we did our class the other day, everybody had their handout, and we actually went through and we highlighted a few things. Today, I'm actually going to show you on the screen a couple of the things that we talked about the other day. All right, AC, alternating current, you guys know the symbol, but if you click it over one click, you will look on your digital screen and it will, I don't know if you guys can see it. Yes, you can see it right there. It actually shows the AC. You should be able to see that on yours as well. Click it one more time and it actually shows the DC for direct current. All right, now when you do that, you are limiting yourself to those two currents. If you actually flip to the off position, click one click to the left, it is actually set to auto to either one. So that is the one that I recommend when you're learning to use. Always click it over, one click to the left. So when you actually start scoping and finding voltage, you will actually, it will find it for you and tell you which one it is. And it will actually notate it on your screen. This one is actually defaulted to set at DC. All right, most of you guys actually did your assignment. You actually completed your task to where you actually did some field measurements and got some voltages. If you guys would, I'm going to ask one by one. You can unmute and just respond to me as I ask you. Matthew, what is one thing that you noticed when you were checking your outlets?
That the further away I got from the switch box, it would drop very slightly in voltage.
All right, the voltage would drop slightly. All right, very good. Max, what did you notice about some of the batteries that you checked?
Most of them had the exact same voltage.
Had the same voltage?
Yeah.
Right. I'm trying to think of who had a different voltage than what the battery was rated at.
Mine actually on a AA battery was like 0.3 volts lower than it was supposed to be.
0.3, all right. So everybody understands DC is a held charge in that battery. So if it was showing less than the 1.5, that means that it is actually not holding the charge. It's actually been used. It could be old, or it could have actually been used in a device that actually used some of that energy. Danny, it says you're raising your hand. What would you like to say, Danny?
I don't know how I did that, but just disregard it.
I thought that was me.
Oh, it said Danny.
Maybe we both did it.
All right, so very good. You guys did that. Who had a...
I got a question, though.
Yes, what? Sorry, you didn't have to say that.
Well, okay, sorry. So we have the auto option, but then we have the option that has both. What's the difference in...
I will research that and tell you that answer. Very good question,
All right.
son. All right. Max, I know you were doing one of the outlets in our dining room. What was the voltage on that one? Do you remember?
Yeah, just give me like 3 seconds. And
It
I'll
was
tell you.
actually 122.6. I remember it because I actually wanted to use it in this class today.
And then I had one that was 124 up in my room.
All right, so 124. Now, I want you guys to understand this. The power company has to send you a voltage in a range, all right? It can be a little bit higher, it can be a little bit lower, but they cannot send it below that set amount. Does anybody know why they could not send you less voltage?
Because you are like, what if you have something that is maxing it out and you can't power it?
All right, couldn't power it. That's a good one. Matthew, why do you think?
Certain appliances need a certain amount of voltage, that and they
Right.
could be cheating you out of money.
All right, they could be cheating you. That's one way to look at it. That is very true. And that actually does happen in the commercial side, but in a residential setting, your equipment is designed to run on certain. If you have less voltage, number one, it's going to affect the performance. Okay. So,
Yeah, because then it would have power, but it wouldn't be able to do what it needed to do.
right. It will not do exactly what it was intended to do. Now, the number one example for that, which we all, unfortunately, in today's society have, and it's got wood shavings on it from being here in the shop, a cell phone and a charger. If that voltage on that charging block, brick, whatever you guys want to call it, is less than what it is set to be, it will not charge your phone. Now, at your house, very seldom will you get less voltage than what you're supposed to get. Normally, you will actually get more. And the reason why is they give you more. So like Matthew said, the further away you are from your switch box, it equals itself out. Does that make sense? My little rough explanation. Anybody got a question about that? Now, Matthew had actually said something about costing you money. Just imagine if you run a factory that is turning big motors constantly to produce a product, and the power company is giving you less, which means your motors are turning slower, therefore your outcome is going to be less. So they actually, large companies have in their facility a device that tracks the amount of voltage they get, and if it goes above or below what they're supposed to, it triggers an alarm, and it actually makes a recording, and they will actually ask for a credit back on their electric bill. I know that sounds crazy, but if that happens 10 times in 1 month and it's going to cost them $10 every time, they just saved $100 by the power company's shortchanging. Does that make sense? Everybody give me a yes if they agree.
Yes.
Yeah.
Yes.
All right, good job, Smiley. I got to hear your voice.
Woo!
And Smiley, I do apologize. I wish that I had thought before you left to give you a multimeter, but we will get you one, I promise.
Okay.
All right. So you guys actually went out in the field. You actually stuck your multimeter leads into outlets. You did batteries. Caden Tripp's not on here. He actually has to video this because he doesn't have real good internet at home. But he went out and actually tested his car battery, and his car battery came back at 11.9 volts. Does anybody know what a car battery is rated at?
Well,
12 volts. All right. Does anybody know what the vehicle charging system is rated at?
what do you mean the vehicle charging system? Like the
What is it? What is a vehicle charging system supposed to
Well-
charge a car battery at?
12?
14 volts.
Wait, oh, I thought you were meaning like the thing that you plug your phone charger in.
No. A car charging system, alternator on your vehicle,
Okay.
is designed to charge at 14. Why would they charge at 14 when the battery is only rated at 12?
Because it's going to be using power, so they need to give it more. to
All
keep
right,
up.
so residual, drain down, and then also a little overcharge. So when you do use it, it will still have that charge. And then batteries are actually rated on that. We're not getting into amps yet. That comes later when we start using the clamp-on meter. All right, so what I want to do right now, I want to show you guys a typical field measurement voltage in your house. Now, you can see right behind me, I'll point. You can figure out right there. Slide up. Right there is your, it's so hard to go opposite. Right there is your main lugs coming in. Now, Tate Weathers actually measured his main lugs coming into his house. I would not recommend you guys doing that yet, because you guys are still a little green. And the bad thing is, those lugs will always be hot because you cannot turn off your meter outside. Everybody understand what I'm talking about?
Yes.
Okay. You do not have a breaker like we do to where I can turn off your power at your house. Oh, look, I can point this way too. I forgot. Anyway, I'm going to show you a typical measurement on a house. Number one thing, remember, this box is always going to be hot at your house. So do not lean up against it. Do not trip. If there's stuff in the floor around it, move it out of the way. There's no reason, like right behind me, Tate's bag, every time I move, his bag's hitting me in the back. Bam, I moved it out of the way. Now I can get in here. Whenever you're in here, remember, all of these unused spaces are hot. All right, that is 120 on one side, 120 on the other, which brings up the 240. If
212.
breaker at home, this stays hot. This will actually become dead. Does everybody understand what I'm talking about? Give me a yes.
I see.
Yeah.
Yes, sir.
Is that Gavin?
Yes.
Good job, Gavin. I was afraid you fell asleep.
Shit.
All
I
right,
feel
so
like
when you do this, I showed Max last night, push your illumination button on. Everybody do that real fast. You know what?
Illuminate.
Do this. Hold that up to the screen. Illuminated. Matthew or Shane Wiglet. There you go. Is your
Everyone illuminate. Press the light button.
see the light button on the side looks like a sun?
Dude, Smiley's doing it the best out of all of us.
He does really good. There you go, Shane. Matthew.
I know I'm a little stupid.
It's really hard to see Matthews, but all right, very good. Gage, good. Gage, did your dad actually show you any more tricks and stuff?
Not right now, but he brought me like we got boxes and stuff like this, and he's gonna.
Oh, hang on, let me see. Let me
I'm
see.
gonna
I done,
got
let
like
me see.
all this stuff.
All right, you got to wiggle. Oh, there we go. All right, good deal. What's neat is I'm hoping that you'll get to share that whenever we come back to school.
Yeah,
right,
I'll
so
bring it
everybody's
to
got-
school when we come
Sharing
back.
is caring, except for coronavirus.
All right, so everybody's illuminated. The reason why you do that, you do not want to get in there and get a misread. Now, when you go in and actually test one, now, just for video purposes, I'm going to go in Smiley's booth, which is hot, and take a reading. I'll be right back.
Super hot in Smiley's booth. Well, now. Jackson Smiley Wilkins is in here. How you doing there, Shane?
Wait, so are these digital meters?
Who asked if they're digital? Yes, they're digital. It
Yes.
has an LCD screen. All right.
Right,
I
little
win.
thing floating
It's
around.
analog.
No,
It's
they're not analog. All right, now look. I went. All right, no back talk. On the screen, you will see I went to Smiley's. Look here, I'm going to show you right now what I did. This is on Smiley's box. Not really. You go in, you touch one jack, you touch the second jack. You notice how I'm not leaning in here, I'm not actually standing on top of it. You respect the hotness, okay?
Respect.
What I did, while that is on the screen, you hit the hold button. You got to see the hold button right here.
And it freezes it?
That will freeze on the screen what you read. Now, I'm going to open this up. I want responses. Why do you think you want to hold that?
So you can.
So you can check afterwards, like to once you
All right,
get
Dana?
away from the what's hot, you can still look at it.
Very good, Smiley Danny. That's very excellent. That is actually the truth. There are times when you don't want to be standing that close to something that is hot. You hit the hold button and you step one step away from it and you look at it and you're like, something's wrong. What could be wrong with that?
It could be reading it wrong, potentially.
All right. What did I say that when we measure an outlet, how much is an outlet?
120.
All right. So what is 120 plus 120?
240.
240.
All right. Look how much we have.
210,
11. Why
Yeah.
do you guys think that we are at 211 instead of 240?
Because it's traveling.
All right, traveling, that's one thought. All right, to be
Because it's
honest with you, our school building is set up on three-phase. We have transformers all throughout this building that transform that power down to different voltages. The panel that we have actually tapped into is called a 208 panel. Now, you guys are going to be amazed. I'm going to show you something. Watch this. You know what? I'm just going to do it. All right. I'm actually going to release the hold button. Now, I'm going to test Tate's outlet.
This Bluetooth is annoying. Max is over here looking all kinds of depressed.
no, I'm trying to research this.
No, you just look.
All right.
Hello.
Here is Tate's outlet. What does that say?
121.
0.7.
All right. Now, how did we get from 208 to 121?
Breaker.
No. This is a
limiting?
208 transformered box. So when you add the 120 and the 120 together, it equals 208. Now, Smiley, I know that you are either the smartest or the second smartest, which we're supposed to find out this week. How does that equal 208?
It's not supposed to.
All right, it's called electrical. Remember, I told you in the beginning, 2 plus 2 equals 3. Remember that crazy math I did that first day that you guys were in here and you thought I was super crazy and you're like, man, he's...
Still do.
Thought you were super crazy.
What, Shane?
What? We just
Maybe
thought
not.
you were super crazy?
All
Nah.
right, so anyway, the reason why you're getting this voltage here at school different than what you get at home is because of the transformer that we are connected to. Everybody understand that?
Yeah.
So
Unfortunately.
they actually connected to his, he got the 240. If you guys do it at your house, you will get close to 240. Shane, I'm hearing all that back noise, so I had to mute you. All right, so anyway, there is our very simple how to use the multimeter to go and measure voltage in your house. Now, the hold button we didn't talk about the other day, now you guys have seen it. What I want you to do right now, while you're sitting there, standing there, sleeping, whatever, go to a plug-in and actually get the voltage and then hit the hold button. And I will sit here and wait. Smiley, just pretend like you're going to an outlet.
I could call somebody and put them on hold.
Hey, are you guys leaving the house or are you guys quarantined 100%?
We're just trying to stay here. We'll
Okay.
only leave to go to the grocery store.
All right, because I was going to say, if I don't know if your mom would let you, or if you went to a Lowe's store, I could buy a multimeter at that store and you can pick it up. Or, I mean, I can mail it. But what I do got to get from you, if you want me to mail it, I just need to know who to send it to and then put to your attention.
Do you think a Home Depot would have one? Because there's one of
Yeah.
those like really close.
Yeah, I mean, I could call Home Depot there. Is it in Conyers or in Covington?
It's in Conyers, but I could just go get it.
No, because it's $100-something. This would be coming to our school.
Yeah, never mind.
Yeah, they're $100 for these. All right, will everybody get a reading other than Smiley?
All right, I got a question.
What?
Would the fact that yesterday I only had one thing plugged into an outlet, then added two things because I have an extension cord, would that drop it at all?
You do the math and I'll sit and wait.
So yes,
Yes, all right, thank you.
because it dropped it too.
All right, now just imagine, I wish we could do this, but we're not gonna do it today. I would love to be able to do it here at school when you guys are here. We actually plug in a hair dryer and turn it on, you guys will be amazed at what you see.
Which I don't even have my lamp and stuff turned on.
But it still, it takes electricity to run up to that switch.
Yeah.
So everybody got it? Hold them up. Let me see them. All right, 122.2, 123.2, 121.3. Gavin, yours.
I said mine was 122, but I forgot to hold it.
All right, we'll do it again. Let's see if you know how to use the hold button.
What
I
is
just
mine,
put
Father?
mine in the group chat.
Did you?
Yeah, I put the number in for it.
Mine's 5.551.
No, the group chat for the Zoom thing.
Oh, down here.
Yeah.
Is there any way I could share that?
What do you mean share it?
I don't think it'll let them see what you're.
Let everybody see?
Yeah.
Probably not the recording, but it would let everybody else in the Zoom meeting can see it.
Do you guys see it now?
No. One of the problems with the Zoom is that whenever you try and screen share, even if the Zoom stuff is on your screen, we won't see it. It automatically hides it.
Well, that's big stupid.
Yeah, I know.
Gavin,
Father?
122.0. What?
This document says that the auto automatically selects AC or DC volts based on the sensed input with a low impedance, but the megavolts one with both AC and DC, it says AC voltage from 6
All right,
to
we'll
600
talk about that later. Thank you. Good deal. All right, we don't want to start getting all that extra. That's too much stuff right now. All right, so everybody with me. You guys figured out now, number one, how to use your illumination button. You also learned how to use your hold button. And then you learned how to use your selector switch. Everybody with me?
Yep.
Oh,
Yes.
Yes.
Shane, why did you send that to Smiley? Anyway, who cares?
I told him to unmute his mic earlier when all that background noise was, or to mute his mic, and now he just saw it.
Oh, okay. It took him a little while. All right. Well, I
Yeah.
can mute his mic earlier. All right. So everybody, do you feel comfortable now actually getting a multimeter and going and figuring out which way to select it? Now, if you know all you're going to be measuring is AC, flip it. You know you're going to work on a car, flip it to DC. But if you don't, that is the super wonderful thing that is important about of digital meters. It has the auto function. All right. Now, what if I have it in DC and I measure AC? Have you guys tried that?
Blow
All right.
blow it?
No. Put it on DC and go try it. I'll be right back. I'm going to try it too. All right. What did it do? Matthew, did you do it?
Yeah. It's kind of jumping around a good bit.
It
Yeah,
jumps
it's
around.
jumping.
All right. But it never does lock on.
No,
Why does it not lock on a voltage?
because the voltage is changing. It's moving.
Because the voltage is changing. It is not a set measurement because it's in the wrong setting. You guys see what I'm talking about?
Yes.
Now, did it hurt it?
No.
No.
No. You know how I know it didn't hurt it? Because it comes right back on. It's not hot. It's not ooey gooey. And it didn't sling it across the room. Now, you guys were joking, asking if this was a digital multimeter. 100% this is a digital multimeter. I could get an analog, which we have one down in the cabinet, come up here and put it on DC and do it, and you guys would see me burn my hands. And no, we're not going to try it. But that is what the old analog multimeters would do. You had to determine what you were going to do. And if you did a mistake, you went and bought a new one. And then you try to figure out how in the world you're going to get it off the roof because it slung it up on the roof. Okay. Now, what I'm going to do in the background, I could get this crazy thing off of here. You guys don't see this box, do you? You guys see the box on the right?
Is it the box with all of the people
What
on
Yeah.
it?
Yeah.
No, we don't see that. If
Alright.
if they're in full screen, then we will see it on our side, but not on your side.
Okay, I was just wondering because it was interfering. Now, here is the number one reason why I love the multimeter when we're doing residential Romex wiring. You guys remember when you put your double gang box in, your wires run down through here. Nobody took a marker and wrote on them what they were, correct? Correct, all right. Now, instead of, just imagine, this is not in our booth setup. This switch box is on the other side of the house, 58.7 feet away. You would not be able to look and say, oh, I can tell, here's my hot. What you can do in that case is you actually take your wire and you twist the black and the white together at your location. See, the black and white is twisted. Then you go over to the switch box and you find that wire, and then on the other end, you would do this. You would put your meter, see where I've got it set on the continuity test. You would actually take your multimeter and put it on the black and the white, and when you find the one that tones out, which beep, when it does that, you guys hear the beep, that would tell you which wire it is. Does that make sense?
Yes.
Give me a yes if you
Yeah.
agree.
That was what I asked about
Yes.
before.
Yes.
The last
Yes.
one.
All
Yeah.
right. So just imagine you can see in front of you, you twist the wires together. That actually makes those two have continuity, right? That makes that set of wires go. Now, here's the neat part. Remember, this is the wire that I showed you earlier. This is my equipment cord, power cord that has been sacrificed for demonstration purposes. Now, when I put my meter on one on each side, it shorts it out. Now, does anybody know another reason why that would be good to do that with this little piece of wire? What did I just do right there?
Confirm if it had any breaks in it.
It confirmed that it is not broken, it is solid. Now, here's the neat part about this. If I untie these, I actually grab a hold of that white, and then I come over here. I can do the same thing individually. See what I just did? All right, you go right here to this one, go to the black. This is where you wish you had three hands. And it is together. And then the ground is the same way. If I can hold it, you touch the ground and the ground prong. That tells me that this wire is not broken. It would be a good replacement. Okay, so that's one way that you can use the multimeter when you're troubleshooting. Because I promise you, there are many loss over construction workers, over electricians. They forget to bring their Sharpie to work. They're not going to tell the boss. Guess what they're going to do? They're going to forget to write on it because they don't have anything. And we're going to have to troubleshoot. Now, in our box, big deal. We got 4 wires. A residential house, 2,000 square foot, will have a few wires ran to the switch box. Stay with me. Can you imagine if now that Smiley came to work without a Sharpie, he forgot to label this. So now it's time to start figuring out how we're going to wire our switch, because remember, you got to know which one's the hot, which one's the light leg, and which one is the 14.3 going to the other side of the room. Can you imagine Smiley lays out that day? So I make Max and Shane trim out what Smiley worked on. Guess what they're going to do? Number one, they're going to cuss. They're probably going to text Smiley and tell him he's a loser. Then they're going to have to figure out, by touching these wires together, going 58.7 feet on the other side of the house, and somebody's going to sit there with a multimeter and find that wire. Okay? Does that make sense?
Yes.
Anybody?
Yes.
Miley?
Yes.
Yeah.
Now, here's a bad thing. You're over here at the switch box. Bam, I'm all the way over here, 58.7 feet away. I know it doesn't look like it, but I'm that far away. I'm sitting here finding Smiley's wire that he forgot to label. There's 2 wires that tone out. That means they do that. What do you think that could mean?
The 2 wires are joined somewhere.
Right,
Maybe
wires-
something got a staple cut into it, maybe.
There, man, a live fist bump. That was wonderful. Staples, when you're stapling your wires together on the boards, if you go too deep, which means you hit it too many times, and it actually cuts the Romex, the plastic, and it pierces into 2 wires, it is called a dead short. The exact same sound happens to that wire. Now, is that going to make you mad, Max and Shane, because you're trying to find Smiley's wire? And now you have 2 wires, you got to figure out which one it is?
Yeah, definitely.
You think it'll make you mad? But guess what you do? This is what I promise you. You guys won't believe me. You're smarter than everybody else on the job. All right. So Max is at the switch box, and he's got this going on. All right. He hears this. He is talking by radio, probably by a walkie-talkie to Shane, 8 feet away, probably yelling, "Yo, knucklehead." But we're going to be talking on a walkie-talkie. All Shane has to do. Why did that not work? Of course, it's not going to do it because I need 3 hands. All Shane has to do is unconnect them. You see what I'm saying? Now, what does that tell you?
That those wires were the problem.
That those wires are the ones you're looking for.
Yeah.
Shane undoes this, and it still does it. What does that mean?
There's
That's not
another
the
problem.
There's another problem. That wire that he's got toned out right now, number 1 is not the wire he's looking for, but he needs to identify that that wire is shorted out. Now, the best part about this demonstration, and the best about Shane and Max finding Smiley's mistake, we just found another mistake in our house. Guess what? Now is the time you want to find that. Anybody know why you want to find it now?
So you don't have to go through the drywall later and replace it.
Exactly. You don't have to bust through the sheetrock to find that screw or that nail or something that is shorted out. So you go through and you look and you figure out, we found which wire it is. It's the wire that goes 99 feet and it's going out to the garage to power the garage door opener. You know, somewhere between the garage door opener and 99 feet of wire is a staple that somebody put in too far. All right. You know what normally happens? Carpenter had to come in because a woman or the homeowner wanted them to move a window 3 feet to the left because her couch fit right. So when that carpenter came in and he started driving nails, he could care less that Gavin's wires up here. He could care less that Tate was here for a month wiring his house in. He drove his nail right through one of your wires and didn't tell anybody. So then you find it. You know why I blame it on a carpenter? It's interaction from students.
Because they're most likely to do it.
Because they're the most likely ones to do it and not tell you. If an electrician makes a mistake, you don't want anybody to know it because you're smarter than them. So you fix it before anybody finds out. I would rather one of my employees come to me and say, "Hey, we 9 feet of wire. It's got a cut in it. We need to fix it," instead of hiding it and then the drill in. And then I'm like, "Gavin, you're the one that ran that wire. Why did you not tell me that you put a nail through it or you put a staple in the wrong place?" So it's a whole lot easier to identify your mistakes as you make them and fix it than it is to hide it and let it go on. Everybody understand what I'm talking about?
Yes.
Yes.
So now,
Yeah.
in Smiley
Yes.
Box, Smiley actually worked with the ground fault, and we had an issue. Smiley, do you remember what the issue was?
Unfortunately.
All right, nobody else does. We'll keep it a little secret.
Hey,
Smiley actually hooked up two hots to his ground fault by a very simple mistake of hooking up a double pole breaker to his GFCI, meaning he put black on one, white on the other, which is what we did on our prior outlet. So very common mistake. Now, there is a way that we could troubleshoot that without even taking this out. That is the neat part about multimeters. With this being in the wall, and I wish it would be clear to where you guys can see it, you can actually touch these joints. See that screw? You can touch that with this being in the box. You guys know what I'm talking about?
yeah.
So if you reach in there and you touch this and it says 220, you know what the problem is. Okay? Instead of having to take all the screws out, fighting with the wires that have to be pushed in there, you can find your mistake instantly. All right? The best example of that is on a switch. Switches are always the problem when it comes to electricians and apprentices wiring stuff. Because just like Shane, you remember on yours, you had one wire cross. Big deal, we fixed it. That is the number one problem. When you have multiple wires coming in, and you're telling me to put black with white and yellow with this and orange and green and all the colors, your mind, all right, maybe he said orange to green, I can't remember. Very easy to get these mixed up. Instead of having to take all this apart, you take your multimeter leads, stick right in beside here, you can find it. All right? Now, will this fix it?
No.
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 The main
It'll
thing
take the
you're using
problem.
this for in residential wiring is to troubleshoot. Okay? Now, Matthew said something the other day that I thought was wonderful. It's great because it made me think of what we used to do out in the field. Every good electrician will have one of these in their van or their truck or their car, whatever they're driving. It's just a 20 or 15, I don't know how long this one is, probably 25-foot extension cord. This now becomes an extra long set of multimeter leads. All right, I'm going to show you what I mean. You guys, if you have popcorn, now would be the time to eat a bite. All right, no more eating popcorn because I don't have any, so you can't share.
Looks like we lost Gage.
Do what?
It looks like we lost Gage.
Oh, he fell asleep. All right, so here is your multimeter. I set it to auto. Here is the end of my super long multimeter leads. I actually stick this inside of my multimeter leads. And look what I've got. And I'm nowhere near that outlet. What am I measuring right now?
The voltage of the outlet.
The voltage of the outlet. Smiley, did you see that?
But what if there's like
I
a
did.
mix up in the huh?
Say it again. I didn't hear you.
What if there's like some kind of mess up in the extension cord?
Very good question. Thank you for asking me that after I've done hooked it up.
What?
I said, thank you for asking me after I hooked it up. Every good electrician has good equipment. I promise you, cross my heart, stick a needle in my eye, look up to the sky and tell you, I had the best equipment of anybody that we ever worked with. People came to us to borrow our equipment because if we're out on a job site 59.7 miles away from my house, I don't want to have a cord that could be bad. Do cords go bad?
Yes.
Because people actually run over them, people cut them, they burn them. All that happens on a job site. So the best thing to do is to make sure that your cords are good before you start troubleshooting with them. And the way you do that, you guys hear the beep, you check the continuity in all of your joints. Now, Max, very good question. I just showed you this cord is good. Okay. All of its functions are working properly.
So is there even a possibility of it losing voltage as it goes through?
Well, of course, it loses a little bit of voltage.
Well, yeah, but drastic amount.
No.
That
Now,
would
if this
mean that the
was,
cord's broke or something.
yes, or this cord was like 975 feet long, and it was such a big spool that I had to roll it up here with a horse and buggy to get it up the steps, then yes, when I plugged it in that outlet, it would show a different reading than what is over there. But when you're troubleshooting, you're not trying to pinpoint a, sorry, I was reading a text I'm not supposed to do. You're trying to verify that there is power there and that there is not a problem there. If you're 2 or 3 volts less, we're not worried about that. We're just trying to make sure that we have that wired in correct. So that is a good question. Yes, your cord could actually lose voltage if it's 997 feet long. It took a horse and buggy to carry it up the steps. Or, like Matthew said, your cord has a short in it, and it's not a dead short, just a short. It's actually a drawing short where you're losing voltage, and it's heating up, and your cord's actually getting really hot, and it stinks, and you don't realize it, but it's actually melting to your boot. Then yes, that would make the voltage be less. All right, so don't want to get off track. Now, when we did our outside light right here, this light was connected into here, but we already had other wires in here. The neatest part about a multimeter, you can use this to test different things. Now, inside an outlet, inside a keyless fixture, but every fixture that we have today in America has a bulb that either screws in like this, or it has pins that go in and you turn them. You can actually use your multimeter to test that, and also to find this wire, even with this keyless fixture on here. If you guys could see it, I can't show it close enough. I might be able to, since I have the capability. If you look inside that keyless, do you see that gold color?
Brass pin, yeah.
Yes.
All right, the brass color, but it's kind of gold. That is your hot. Anytime you're looking at a light fixture that has a screw-in bulb, the center is your hot. So if you actually try to figure out the voltage, you have to touch that brass piece. Now, the worst part is the metal ring around the outside is ground. What happens, and now, believe me, this is actually in our manual. If you have multimeter leads that are 1 inch long, all right, you see these are about 1/2 to 5/8. What if you have them that are 1 inch long? You reach that multimeter lead in there, and you touch the hot while you're touching the ground. You may know what would happen.
Do you get a bad reading?
You would get a bad reading as you're having to go and empty your pants, because it would short out right there up above you, probably send a spark, okay? And it would probably cut your multimeter lead tip off. Have I ever done it? Yes, I have. Have apprentices done it? Yes. That is why they come up with this neat thing on these multimeters, where these multimeter leads actually come out, and you can go on Amazon and buy these probably for $9. And remember, a good electrician would probably have extras, because yes, it happens. With me. So now Smiley already wired in his keyless. He ran his wire, but he forgot to mark it again, because Smiley, it's terrible. He never brings a marker. Now he's got to find that wire. All you have to do, stick that in there. And if it's a short distance like we are here, and you're ambidextrous, you can actually stick it in here, over here, and find it. But guess what you can also do? Smiley, I bet you already know. Short out your wires again, black to white. Okay, black to white. Then go up here to the light, the keyless, and actually touch the ground and the hot, and you'll get the same beep as you do if it's something else. All right, do you guys see what I'm talking about? This is very, very handy. You will use this a million times when you're doing residential wiring. Number one, to troubleshoot, try to find your mistake. Gage, you remember in yours? Well, he's gone, but he had a wire loose. We actually
With my lot.
Yeah, he made it back.
we measured the voltage, and he had voltage going up to his lot. So then we took it down, and he had a connection that was loose. All right. So we use this to troubleshoot. Now, did we have to use this?
No.
Shane, what is Big Sad? Anyway. He's still on the muted. Anyway. Shane, you're allowed to come unmuted when you need to talk. But don't interrupt when I'm talking.
Don't tell him that.
Sorry, Gage. All right, so we use this, but did we have to use this, Gage, to find your fault?
No, because I had that bad, what do you call them?
Keyless?
It wasn't keyless, it was just how I did the wire.
Okay, but I mean, did we have to use this to find it?
No.
All right, Gavin, what do you think this does when you're trying to find fault?
It tells you which one it is, because like you said, you could tie them up together and see if it's that and if it beats.
Okay, but what does this do when you're troubleshooting, Smiley?
Saves you time.
There we go.
There we go.
Alabama, I was afraid it's going to go to
Easier.
everybody. Yes, this saves you time. Do you guys see right now, look inside your box, this is everybody's box. Don't look at tape. This is Gavin's box. This is Max's box. This is Matthew's. This is everybody's box. Do you see how this would come in handy?
Yep.
Yeah.
Max?
Yes.
Smiley?
Yes.
Yes.
Shane?
I actually needed to use it for my GFCI since it wasn't working.
All right. So yes, this actually can help you tremendously. Okay. Now, when we actually get into voltage and we're like, how come this light in this house never surprised? You can use this to go and see, and it's crazy, but you can actually have an overloaded neutral. Neutral on our box and tape is on the right. It should be on yours, but it might be on the left. It is on the right side in Tate's. If your neutral is overloaded, you have too much going on your neutral, it will actually make your lights dim. Now, here's the bad thing. The older house trailers, you guys remember, you guys probably don't remember, but before you were born, house trailers burn a lot. The reason why is because they use aluminum wiring. Aluminum actually expands and contracts a lot more than copper. The old house trailers, you went into a house trailer and the neutral connection would actually be red hot. I personally have changed out the neutrals on house trailers because they were too small. The lights in house trailers used to, they were, and they were always flickering. The reason why is they overloaded. The best way to find it is with a multimeter. Use this to go in, do some troubleshooting. Today's standards on house trailers, mobile homes, all that stuff, it's totally different. They actually have to follow the same guidelines as regular houses do now. Because we actually used to live in a single wide trailer. We never had issues with it because it was a newer model. Talking about like an 80s model versus a 70s that had the old aluminum wiring. So don't worry about your house right now having an issue. The old ones. Now, if you have a 1960s, we'll talk and we'll fix it for you. But anyway. All right, so I'm going to try to wrap up. Anybody have any questions based on what we did today, demonstrating the proper use of a multimeter in our residential booth to troubleshoot and to measure? Go ahead, questions.
So there's a minimum maximum on this. In what situation would you use the minimum?
That would be
I
when,
can see maximum.
right, because you don't want to overload something. That would be like if this laptop that I'm working on right here, this Dell, says that it's operating, its normal operating conditions need to be 105 volts to 130. and then we only have 103 coming in, we can't figure out why our laptop's not working, then we would know that. I mean, then we would need to know that.
So it'll tell you if it's below
Right.
what it's rated for.
And also, I'm thinking, and this is me thinking, so don't quote me on this,
Which
but I think if you hit the minimum and maximum while you're measuring voltage, it will actually lock in on the screen.
yeah, it does. Before you had showed us the hold function, that's actually what I did for the outlet, because I was wondering what the min-max did.
All right, so what that is, that would tell you how much your current is fluctuating.
The minimum and maximum current going through it.
Right, so that would mean that your voltage coming in, if your minimum is like 110 and your maximum is 140, you have an issue. That means you have a 30 point spread in your minimum and maximum. Does that make sense?
Yeah.
We'll talk more about that as we go on in the multimeter, but as far as demonstrating the proper use of the multimeter, does anybody have any questions about the little bit that we did today? It's already been an hour. I can't believe it, but you guys probably feel it's been, I don't feel like it has been. Any questions?
Mm-mm.